So in this video, we're going to look at 6.08, normalized data. So here's one that's just like here, question number 1. We have the height of 16-year-old boys in the United States is normally distributed with a mean of 68.3 inches and a standard deviation of 2.9. So what this means is that in the center, you're going to put so you label the curve entering the value of each standard deviation in the box. So at the center, we're going to put our mean, so that is the 68.3, and then you're going to add 2.9 going up because that's each standard deviation. Then you're going to subtract going down. So let me get my calculator. So you're going to add 2.9 going up, so that would give me 71.2 and 74.1 and 77. Little bitty boxes right here. All right, then going down, we have to subtract 2.9, so that is going to give me 65.4, and then I'm going to have 62.5, and then we have 59.6. So that's how you would write your standard deviations, okay? Just labeling the normal curve. So what percent of 16-year-old boys are between 62.5 and 71.2? So 62.5 is at the -2 standard deviation, and 71.2 is up here at the 1 standard deviation. Because remember, the middle is 0, 1, 2, 3, you got -1, -2, -3, and so on. And we'll look at those numbers more in detail when you start looking at z-scores. All right, so we have our percentages. So go to your normal curve and look at your percentages. Remember, you got 68 in the middle, so that means you've got 34% here, 34% here. Then we have 13.5 here. And then you've got 2.35. And then on the very end, you have 15%. So you may want to keep that written down. Okay? Or 0.15%, not 15%. 0.15%. All of these are percentages. So between here and here, I'm going to add up 13.5, 34, and 34. Because that's from the 62.5 to 71.2. Add those up, and you're going to get 81.5%. Okay, so you'd put 81.5 in the box. Okay. All right, so let's look at a problem set number 2. So the height of 14-year-old boys in the United States is normally distributed with a mean of 64.5 and a standard deviation of 3.1. So we add 3.1 going up. Let's see, so that gives me 67.6, 70.7, and 73.8. And then going down, we have to subtract, so that is 61.4, 58.3, and I should have made this graph a lot bigger to put these numbers in. And then we have 55.2. There we go. And again, you're just subtracting 3.1 going down, adding 3.1 going up. And your mean is in the middle. All right, so boys between 58.3 and 70.7. So that is within 2 standard deviations. Now don't forget, within 2 standard deviations, we have 95% of the data. Okay, that's your empirical rule, 95%. Okay, or you can actually go through and write out those percentages in each piece and add them up. Either way, you're going to get 95%. Okay? Oh, they are within hold on, it's 95%. Got ahead of myself. It's 95%, but it's within 2 standard deviations. Okay, this is within 2 standard deviations. Okay, see, this would be 1 standard deviation, then there's 2, and then there's 3. Okay, so between 58.3 and 70.7 inches tall is within 2 standard deviations, and it covers 95% of the data. All right, so let's take a look at set number 3. So suppose the lifespans of male mosquitoes are normally distributed with a mean of 15, standard deviation of 2.5. What percent of mosquitoes live between 7.5 and 22.5? All right, so what I like to do is just draw a little line in the middle, put your mean. 1, 2, 3 standard deviations going up, 3 standard deviations going down. So, going up, you're going to add 2.5, so that gives me 17.5, 20, 22.5. And then going down, we have 12.5, 10, and 7.5. So between, what percent is between? All right, so this is within 3 standard deviations. Look at this. Within 3 standard deviations, so from 7.5 to 22.5, that is 3 standard deviations. So within those 3 standard deviations, we have 99.7% of the data. So it's 99.7% of the data. And again, that's your empirical rule. All right, so the second one, suppose the number of nails, box of nails, 5.5-pound boxes of nails with a mean. All right, so I'm going to draw my line again. So the mean is 325. And we have a standard deviation of 15. So 1, 2, 3. 1, 2, 3 going down. Add the 15 going up, subtract it going down. So in the middle, we got that one add. So you're going to get 340, 355, 370. And then going down, we get 310, 295, and 280. All right, so it's between, about how many contain more than 340? Okay, so it's 340 going up. So write your percentages. Okay, now don't forget, you've got, remember, 34 in the middle, 34%, 34%, and then you've got 13.5. And then you've got the 2.35%. And then at the very end, you've got 0.15%. Okay, so add up 13.5, 2.35, and 0.15. So after you add those up, you're going to see you are going to get 16%. Okay, so you should get 16% after you add those up. Let's just make sure of that. So 13.5 plus 2.35 plus 0.15. Yep, 16% for that one. All right, so last one, just like problem set number 4. So in problem set number 4, we have the weights of bags of ready-to-eat salad are normally distributed with a mean of 300 and a standard deviation of 9. So add 9 going up, so it's 309, 318, 327. Subtract 9 going down, so that's 291, 282, 273. Okay. What percent of bags weigh less than 282 grams, 282 grams. So that is below right here. So if you look at your percentages, so you're going to have 2.35% here and 0.15 below. Add those up and you get 2.5%. So 2.5%. All right, let's look at the next one. My line is so not straight right there. It's okay. We have times for ambulances to respond to a medical emergency in a certain town are normally distributed with a mean of 450. Standard deviation of 50. Okay, so that gives me 500, 550, 600, and then we have 400, 350, 300. Okay. And about how many would you expect responses between 400 and 500? So that is within one standard deviation. And don't forget, this is 34%, 34% within one standard deviation. We have 68% of the data. So you can use your empirical rule or you can write down the pieces of your percentages. Okay, let me know if you have any questions, and I hope this video helps you with 6.08.